Okay, I want to look at second stages, downstream demand valves. So the air comes from the first stage at an intermediate pressure above ambient, and that's the pressure at which it reaches the second stage. Now, what is a downstream valve, and why is it so important that it is a downstream valve? Well, imagine if the valve opened like this, with a spring pushing the valve open against the flow of air when the diver inhaled. And then when the diver stopped inhaling, the spring contracted and the valve closed in the direction of the flow of air. What would happen if that spring failed? What would happen is the diver would get no air because the valve is opening against the stream, and that's not a good thing. So let's change the design of this and make it a downstream valve. Let's get rid of that valve there. Let's change the spring a bit. Let's flip that valve over and put it in so it is blocking the orifice in the downstream position. Now with that spring extended, it's pushing the valve closed. There would of course be some sort of lever that's attached to the diaphragm, which is part of the mechanism, but we're going to ignore that. It's not that important. So what would happen when that lever pushes against the spring? It'll push the spring and it'll allow the valve to open. What would happen if that spring or lever failed? Well, that airflow is going to continue pushing against the valve, and you will get a free-flowing reg, a continuous flow of air, which is, of course, a very safe way for a regulator failure to happen. It's better to get lots of air than none at all. And, of course, all this stuff we're looking at is somewhere inside the second stage.